Phase is not the same as DC offset. DC offset is if you have the neutral position and your waveform is moving above and below, and instead of being symmetrical, it's more above and just a little below. This is DC offset. This means that there is a continuous tension, a continuous current that is making the waveform not symmetrical. And the problem with DC offset is that when the speaker is moving, instead of moving from its rest position, which is in the center, forward and backwards, now it has to push more forward and it's coming less backwards. And this is a problem because it's creating more constraint on the speaker, but it's also then creating saturation, because if you think about that, if your speaker is limited in its move, instead of going a bit high and a bit below, it has to go very high, but then very high it gets forced, it gets blocked, and so it's creating a kind of clipping. It's eroding the symmetry. It's eroding the smoothness of the waveform. It's working kind of as a soft clipper. It's adding harmonics. So DC offset is also very important to take care of, but it's not the same as phase. This being said, because phase affects the peaks when multiple frequencies are into play, because it's changing the correlation between all those frequencies, it is also changing the tone as soon as we dial in nonlinear processors. Let's have a listen and a look at the same time. We have here another instance of operator with 4 harmonics playing together, creating this sound. These are all the harmonics we see, and this is the spectrum. Now, as soon as I dial in some saturator, we see more harmonics, we hear them, and we see the sound is rounded off at some points when there are normally 2 high peaks. Now, let's change the phase of one of the oscillators. You see how all the harmonics don't have the same position anymore and how the waveform has changed. This means, even at higher ranges, this means that if I'm putting any filter before a nonlinear processor, a clipper, a saturator, a compressor, a limiter, I am changing the peak relationship and I'm changing the sound of that saturation. Let's try this with a Pro Q4 in all pass mode. Let's dial in a Pro Q4 all pass filter. And let's play this now. You can see and hear how the all pass filter is changing a lot the harmonic content when it goes through the saturator. Let's drive it even more. And we see here it's changing also the phase of the square wave that is generated. Come back to something more gentle. Sometimes a waveform that is symmetrical in general, but at some point there is a peak coming out. And this is where phase can solve things, and this is not DC offset, of course. So DC offset is really like a difference in the symmetry from the rest position, and this can be solved by just adding a low-cut filter, because you are removing a constant voltage. You are just getting that constant voltage down to 0, and so getting back the symmetry. There are also DC offset removers. Even Pro L2 from FabFilter, the limiter, has a DC offset remover, and this is a great thing because DC offset can affect, for example, way on which dynamic processors are reacting, because a compressor is reacting at a certain threshold. So if your waveform isn't symmetrical, the threshold will be hit at one polarity of the signal, but not at the other one, or differently at one than on the other one. So you start to affect the signal in different ways as soon as you add non-linear processors like distortion, compression, limiters, etc. So taking care of DC offset is something that is very important to ensure both the speaker to be able to play correctly, but also all your dynamic processors or saturators, I mean all nonlinear processors, to work properly. And it can affect how a waveform clips. This is why I think as first Isotope RX implemented this phase correction tool, especially for vocals. Sometimes you can see a vocal peaking very highly in one portion of the signal, but not on the other one. On average, it's symmetrical, but at some moment it's hitting. And this is changing the perceived impact and punch of the transients. And when summed back in mono, asymmetrical waveforms might sum differently as well. So this can create level changes also. So there is this Isotope RX phase rotation tool, or in DMG TrackCom2 there is the asymmetry control. This is a way to resymmetrize a waveform without touching the frequency content. Or you could use, as I showed in the example with the kickover bass, you could use an all-pass filter to rotate the phase at some frequency range without altering the frequency balance.